it's Anya. Today I'll be going through how different ideas from this chapter can be applied to real-life situations and professions, particularly the concepts of exponential and logarithmic functions. Let's get started. Alright, so we have Mia. She's duplicating strands of DNA to run experiments on. She adds them to a CRISPR-Cas9 system, which doubles the DNA every 10 minutes. Originally, 20 strands of DNA are put in. How many strands will there be after 1 hour? Alright, let's first start by gathering all of the information we need to construct an equation that will help us solve this problem. Alright, so we know that originally 20 strands of DNA are put in. That'll be our principal amount, so we'll put that on the outside. We also know that it is doubling, so we're going to put a 2 down here because we are doubling our DNA every 10 minutes. Every 10 minutes is extremely important as well. That will be our x value, or what the x variable represents. So our x is going to be the tens of minutes that have passed. This is to make sure that we are correctly measuring how much time exactly has passed and that everything is doubling correctly. So we're going to make that all equal to y, which will represent just the amount of strands that will be there after a time period. Okay, so let's just go through every part of the equation again real quick. So we've got 20, that's the original amount of strands of DNA that were put in. 2 as a base, that represents the DNA doubling. And then we've got our x variable, which represents the tens of minutes that have passed. That is to confirm that the DNA is doubling every 10 minutes. Alright, so we have to figure out how many strands will there be after 1 hour. So 1 hour is equal to 60 minutes, which is 6 tens. So our x value that we're going to substitute in will be 6. 6 tens of minutes will have passed. So all we gotta do is substitute in 6 for x, then multiply 20 by 2 to the 6th, and then we get 1,280. So after 1 hour, 1,280 strands, there will be 1,280 strands of DNA. So this is just one way that exponential functions can be used in the field of biotechnology. It's often used to measure population growth, and it's used quite a lot in finance. So yeah, this equation, or this type of equation, exponents and logarithms, are very versatile and they're used in all sorts of situations and professions. Alright, thank you for listening.